Okay, so you've probably solved inequalities before. I'm guessing this will look familiar. You solve it almost like an equation. So you have negative 2x less than 4 divide by negative 2. So this is the step that hopefully you remember. I'm not sure. Do you remember when you divide by negative, what happens to the sign? The direction of the sign changes. So your answer would be x greater than negative 2 because you divided or multiplied by a negative. Not sure if you've seen this type of inequality where you're solving for x. So the goal is still to get x all alone, but you want to get it all alone in the middle here. So it kind of works like an equation with three sides to it. So I'm going to add 2 to each part here, so to speak. And I get 9 is less than 3x is less than 18. Then I'm going to divide each part by 3. And this is 3 less than x less than 6. So x is in between 3 and 6. You've seen that notation before. I'm not sure if you solved equation in that form. By the way, the same thing would be true. If you divide it by a negative, you're going to switch the direction of the signs. If you multiply by a negative, you're going to switch the direction of the signs, only when you divide or multiply. Let's talk about an idea of multiplicity. So first, let me show it to you, then we'll talk about an example. So here's a polynomial. So it's got x squared here, which causes a 0 right there. X plus 2 at x equals negative 2. There's a solution right there on the axis. And then x minus 3, that third factor there, causes a solution right there at x equals 3. And that's the one I'm going to focus on. So right now, the factor x minus 3 has a multiplicity of 1. In other words, there's only one x minus 3 factor. And the graph crosses through the x-axis. It just goes right on through it. I just highlighted that part of the graph in red to draw your attention to that. If I make the same graph, same function, except I add an x minus 3, so I'm multiplying by 2x minus 3. So there's an even multiplicity of the factor x minus 3. There are two x minus 3s, x minus 3 times x minus 3. Notice on the graph does not cross through the x-axis. It just barely touches the x-axis, right? So it just kind of comes down, touches, and then just kind of bounces off the axis, does not cross the x-axis. I'm going to add another x minus 3 factor. So the multiplicity will be odd. It'll be 3. There are 3 x minus 3 factors there. And the graph crosses right through at x equals 3. Add another one. Now the multiplicity is 4. It's even. And you may notice the behavior of the graph does not cross through the axis. It bounces off the axis. Again, odd. It goes through the axis, the x-axis, and even at x equals 3. It just bounces right off the axis. So when the multiplicity of a factor is even, so if I had something like, even something like this, y equals x minus 5 squared. So if I look at that graph, there's going to be a solution at 5, right? There's going to be a solution right there, x equals 5, because you set each factor equal to 0 to get that solution. And the one thing I do know is the graph will not cross through that axis. You don't have to know how to graph this, but the graph actually is going to have this kind of a look to it for this graph. It's not going to cross through the x-axis because this is an even multiplicity, because there are two x minus 5s. The multiplicity of the factor x minus 5 is 2. If there's 2 or any even number of these, the graph will not cross through the axis at that point. So that's really helpful to know. It's kind of like a nice thing to know. We'll use that in just a minute. So let's talk about linear inequalities. So I guess looking back at those first two examples, these were both linear inequalities. You may notice the x's to the first power, x's to the first power. Those were classic kind of linear inequalities. So let's classify some of these as either linear or not. So this in a linear inequality. It's got x to the first power there, but it also has x to the second, so that would be called nonlinear. It would be a parabola of some kind. X to the third power, is that linear? No, it's got x to the third power. That's a different kind of graph. We haven't learned how to graph that yet. This one, even though it has square root in there, sort of a number, it actually looks of the form mx plus b. Like this looks clearly linear. Mx plus b, the slope is 2/3, the y-intercept is square root of 3. This one you're going to be tempted to say it's linear, but actually, because x is in the denominator, that graph is going to be not straight at all. It's not going to have a constant rate of change. It is going to be nonlinear. And so we don't know how to graph these nonlinear ones yet, but I need you to know the difference, because the first thing you have to do is, if it's linear, you solve it like a normal equation, right? You just have to remember divide or multiply by negatives, which is the direction of the sign. If it's nonlinear, we have this whole other method that we're going to use. So we're about to learn a new method just for nonlinear inequalities. It's called the squiggly line method. And so this is the basic steps you're going to have to do if it's a nonlinear inequality. Hopefully you can look at this one and right away see x squared and go, oh, this is not a linear inequality. So the first step for this is to set the equation equal to 0. Set the equation, or I guess inequality, equal to 0. So I'm going to subtract or add x to both sides here. So I get x squared plus x minus 2 less than 0. So I just added x to both sides. Now I have a polynomial over there. It looks like a quadratic. Second step, factor. And when I mean factor, I mean both the numerator and denominator separately. So if there is a denominator, I want you to factor that as well, because you'll see some problems with denominators. So this shouldn't be too bad a factoring here. So let's factor this one. It's less than there. It's really bad left hand side. Okay, x and x got to be 2 and 1 if it works. Bigger number is positive because that's a positive 1. So plus and minus. Find the critical points. Find the critical points. So in the numerator and denominator, set each factor equal to 0. So in this case, my critical points would be x equals -2 and x equals 1, right? It makes both of those factors set equal to 0. 1 minus 1 is 0. -2 plus 2 is 0. So to find my critical points, the next thing you're going to do is plot only those points. Plot the points on a line. I mean, you can call it a number line, but it's really just, we're just kind of simulating it. So this is just an x-axis, basically. And I'm going to put those 2 points. So 1 and -2 are the only 2 points I want on that line. It's in the line, it basically extends forever in each direction, right? So if you think of this, let's see. So the next step, we basically have to test points in each interval. So we're going to test points in each interval. And just decide if it's positive or negative. Is it positive or negative? That's what we're testing for. So for this, just to kind of give you a sense of what's happening, I don't know if you see the 3 intervals. You've got kind of one interval that goes off to infinity that way. You've got this interval in the middle, and you've got this interval that goes off to infinity to the right this way. So those critical points divide that line into intervals. Hopefully you see the 3 intervals I'm talking about there. And basically we're trying to find which intervals are the solution. So maybe like just the yellow one's the solution, maybe the yellow and the green, maybe the green and the blue there. Just, which of those 3 intervals, could be all 3, could be 1, could be none of them, are the solutions. So we're trying to figure out which ones are the solutions there. Is the idea of what we're about to do. Okay, so we do that by testing points. So let's just start basically, and I'll give you a shortcut in just a minute for testing points, but we're just going to start with basic testing. So I'm going to pick a value off to the right here. So I'm going to pick a value like, in this case, let's pick a value bigger than 1. Like let's test, so I'm going to test x equals 2. So x equals 2. And when I do that, I'm just plugging into the function. So like right here and right here for x, I'm going to plug in a 2. So 2 plus 2 is 4. 2 minus 1 is 1. So 4 times 1 is not less than 0. 4 times 1 is 4. 4 is not that's not a true statement. So 4 is actually well, we'll get to, I guess we'll get to that. So 4 is positive. The big thing is 4 is positive. So in this interval, I'm going to put a plus sign there because again, so I guess let me say, just show you what I did. I did 2 plus 2 times 2 minus 1, which is equal to 4 times 1 is 4, which is a positive number. So any number I plug in that interval, I could have plugged in 10, 20, 100. I'm going to get a positive number when I plug into this thing right here for the x's. So let's test a point in the middle interval. So let's test x equals 0, because I picked a number in between -2 and 1 for that middle interval. It's just any number that's easy to plug in. So if you plug in 0 there, this would be 0 plus 2 times 0 minus 1. So 2 times -1 is actually a -2. That's a negative. So this is going to be a negative in the middle interval there. So I tested one number in there, and all the numbers are going to be negative in this case for this particular thing. And so I'm going to now test a number in the left-hand interval there. So like, I don't know, -5, just any number smaller than -2. So -5 plus 2 times -5 minus 1, which is -3 times -6, which actually is a positive 18. So that's positive. So I get a positive number when I test in that interval. So I've got two intervals that are positive and one that is negative. Well, now you're trying to find out which interval. I guess we need one more little step here. So the little step I guess I need here is we really should have graphed probably at some point here. Are the points, the critical points, open or closed circle? Open or closed. So there's two things you want to look at here. So the first thing you look at is the sign. In other words, this sign is less than right there, which means less than means open circle, basically, right? So I know those are both going to be open circle problems. So on the graph, those are going to be open circle. So the graph, if you think about this is going to be an open circle graph right there. The other thing you want to look at that sometimes make it open right there is if you do have a denominator, which we don't, those points would always have to be open circle. Even if the inequality was less than or equal to, and it would be closed circles, if the factor's in the denominator, it will cause it to be an open circle. We'll look at the example of that in just a minute. So we're almost ready to now, we're about ready to sketch the line. So the last step here will be to sketch the graph. This is like, it's not a perfect image of the graph. It's just a really rough approximation. So we use a squiggly line just to say that this graph is, we don't know what the actual graph looks like, so we're going to squiggle it a little bit. But we do know to the right, in this interval on the right here, the graph is positive, which means the y values are above the x-axis. So I'm just going to start from up above. You know, it kind of goes like that. It's positive. In the middle interval, the graph, the y values are below 0. They're negative. So I'm going to graph everything below 0. So it's below the x-axis. And in the left interval, the graph must be positive because we plugged in a value and it was a positive value. So the y values must be positive. So it kind of looks like that. Again, I don't know what the actual graph looks like. I don't know how accurate that is. But I do know that in the intervals on the ends, it's always going to be above the line. The value of that will be positive, and in the middle, it's going to be negative. So now we have to look back. So I guess there's one more step I should write down over here. So now, so choose the solution intervals. Solution intervals. And so usually this is an interval. I guess every once in a while it's only like a point, or sometimes there's no solution. Those are always possible. So if you think about if you think about this symbol right here, so less than. So I want something that are values that are smaller than 0. So I really want this middle interval because I want negative values. Anything that's smaller than 0, those are only the negative ones. So it looks like it has an open circle. It kind of goes there. So really anything in this interval, in this middle interval, is below the line. So my final answer for what is the answer to this problem is going to be only that middle interval. So in this case, it's going to be, it looks like from -2 to 1 are my solutions. And I use parentheses because those are open circles there. So anything in between in that middle interval, if I plugged in any value for x that is between -2 and 1, I'll have solutions. It'll make the statement true here. So I can try that. I could plug in -1, and I'm going to get something smaller than 0 there. I could plug in -1.5 and get something smaller than 0. So anything in between those two values is a solution for this particular graph. So your solutions are going to be intervals. Sometimes it'll be multiple intervals. Sometimes it might be the intervals on the end and not the one in the middle, or anything like that. So all that could happen. Okay, so let's try one. I'm going to try one with the denominator here. Let's try this one. Okay, so this might be our last problem. This takes a bit of time here. Okay, so we're going to follow the steps. The first step was set equals 0. It's already set equals 0. Factor it. So I think we can do a little bit of factoring here. So up top, this is going to be 2 times x plus 3. And down low, that's just going to be x minus 2, and it's still less than or equal to 0. Okay, find the critical points, right, and draw them on a line here. So that looks like there's 2 critical points. X minus 2 will produce a critical point of positive 2, because 2 minus 2 is 0. And -3 plus 3 is 0, so -3 is my other point. So again, we have 3 intervals here that we're working with. And so we're going to just test some points here. So to test a point, let's just plug in a point, so bigger than 2. So if we plug in like x equals 5. So that's something in the right interval here. We're checking the one, any number bigger than 2. So if we plug in x equals 5, this is going to be 2 times 5 plus 3 all over 5 minus 2. So that simplifies to be what? 2 times 8 is 16 over 3. 16 over 3, the big thing I see there is it's positive, so I'm going to put a little plus sign in that interval. Let's test a value in the middle intervals there. So that'll be like 0. That's the easy value in between -3 and 2. So if I plug in 0, I get 2 times 0 plus 3 all over 0 minus 2. So 2 times 3 is 6 over -2 is -3. The big thing I want you to see, wow, it's looking a lot like the other interval. It's negative right there. And x equals some number smaller than 3, -5, let's make it. So plug in -5, this would be 2 times -5 plus 3 all over -5 minus 2. So -5 plus 3 is -2, that's -4 up top, divided by -7 is a positive 4/7. It's positive, is the big thing I want you to see. Wow, it looks basically exactly like that last interval. And then you would draw your line. Now, I'm about to draw it, but I'm going to show you a short, so, I mean, the line will basically, be positive, then negative, then positive, like the last one. But I'm going to show you a different way to draw that line. So one way to do this is to use, there's a shortcut here. I just want to show it to you. I could have only tested one point here, so I didn't have to test these others because I know about multiplicity. Here's what I mean by that. So if you know about multiplicity, I tested a value that's bigger than 2. So I know this part of the graph does this, right? It goes to that point at 2. Right? It's got to touch the axis at 2 and -3. Those are the critical points. It has to touch the critical points. It doesn't have to go through, but it has to touch. 2, x minus 2, the multiplicity of that factor is 1, which means the graph is going to go through at 2. It's got to touch the critical point at -3. That multiplicity is also 1, which is odd. So the graph is going to go through. So I don't have to test an interval, a point in each interval, if I know about multiplicity. If one of those had an even multiplicity, I would have bounced off the axis and kept going on the graph. It's got to touch all those points. And by the way, this one, because of the sign being less than or equal to, This is going to be a closed circle, closed circle. And I don't, oh, wait a second. Look at this. Because 2 is in the denominator, 2 minus 2 is 0. You can't divide by 0. Uh-oh. I make an exception there. This is actually not going to be a closed circle. It's got to be open because it's in the denominator. So at 2, it's an open circle. The sign would indicate closed circle, but because it's in the denominator, it's going to be an open circle there. So that's what my graph looks like. Now I just have to choose which intervals are the solution. So in this case, we want something that's on the line, equal to the line, or lower or below the line. It says less than or equal to. So where is this graph either, so the middle interval, it's definitely negative in the middle interval. And on that point right there, it's actually on the line. So that's going to be part of our solution as well. So our final answer here is also just an interval, basically from -3 to 2, but it includes the point there at -3 because that's equal to 0. And then it does not include the point at 2 because you can't divide by 0. That would make the denominator 0, and so that's going to be an open circle. Wow. So this is kind of a challenging homework. I want you to try it. And I am going to put up a screencast. So if you look by the syllabus there, I'm going to have a screencast for all the homework problems worked out. So if you want to watch that, it might help you on some of these. I know this is kind of a longer lesson. This is kind of a tougher lesson. This is a borderline what I would call pre-cal type math here. So this is something, a technique that you'll use in pre-cal and calculus and above. So it's a nice technique, but it's kind of complicated. So it takes a minute to learn sometimes.